right, so our last set of notes for the semester. All right, folks, let's get started. Let's stop talking, please. So I want to start with a reminder about graphing inequalities. Just a quick reminder about how we go about graphing these things. So the first step, our first step is always when we graph an inequality, we want to get y by itself on the left-hand side. So we want to end up with something like y is less than 3x plus 5. Y less than 3x plus 5. We want something like that. We want to then graph the line and we graph the line by using the slope and the y-intercept. So we graph the y-intercept and then we count squares to find another point by using the slope. And we use a dotted line for less than or greater than. And we graph a solid line for less than or equal to or greater than or equal to. Solid. And then for the inequality, we shade. We shade above for greater than or equal to. And we shade below for less than or equal to. So this was basically what we talked about on the Friday before break. This was our lesson condensed down into a few lines. Now for systems, and by system we mean two or more inequalities, we do the same thing. For each inequality, so that means we graph two lines or three lines following these rules, shade above, shade below. And our solution is where the shading overlaps. So we're going to shade on two different lines, and the solution to the system is where that shading overlaps. And just a reminder, a solution makes all the inequalities true. So we can plug it into each of the inequalities and it will work in each of them. So I just, yes.
I don't understand what you mean by when the shading overlaps.
When we draw a picture, it'll make complete sense. It will be, you'll be able to see, oh, this is what we're talking about. All right, so I just want to go through a couple of graphs. So that's what our graph paper is for. So for our first one, we want to graph, or we want to find the solution by graphing. Graph y is greater than or equal to 2x minus 1, and x plus y is less than 2. Now our first step always is to get y by itself on the left side for each of them. So for this first equation, first inequality, we're okay. For this one, I need to get y by itself. So I'm going to subtract x from both sides. And when I do that, I get y is less than, and I'm going to write this as negative x plus 2. So one equation, or one inequality, is this one. And one inequality is this one. Those are what we're going to graph. All right, so let me draw my graph here. I should have gotten a grid page, but I think we'll be okay here. You have a nice grid there, so your graphs will turn out nicer than mine, I think. All right, so for this first one, it's greater than or equal to, so we know it's going to be a solid line because of the greater than or equal to, and we're going to shade above. Because it's greater than. So let's graph this line. The y-intercept is -1, and the slope is 2. So I'm going to go up 2 and over 1. And now I'm going to graph that line. Yeah, I don't want that. I want this. Actually, I want this. I'll do it like this. So there's the graph of that line. And we're going to shade above. So if I start on my line, I want to go up here. So I'm going to shade this way. There's this first one. For this second one, we're going to graph it dotted because it's less than. There's no equal. And we're going to shade below. So let's grab this line. I'll do that in green. The y-intercept is 2. So we're going to start here. And the slope is -1. So I'm going to go down 1, over 1. And we'll do that one in green. So there's the graph of that line. And we're going to shade below. So I'm going to shade here. And over here is where the shading overlaps. And if I continue these blue lines, they'd keep going here like so. Our solution to the inequality is this entire place where the shading overlaps. Any point in this area where the shading overlaps is the solution to that inequality. And usually with these, all we do is graph these, and we do the shading. And where our shading overlaps shows us where the solution is. We don't have to draw an arrow or anything. We know where the solution where the shading overlaps is where the solution is. And we can check our work because we can pick any point in here where the shading overlaps and see if it works in our inequalities. So if I wanted to check, I'm going to pick a nice point. A nice point here is 0, 0. I'm going to check by plugging 0, 0 in. Yes?
When you say solutions here, is that when the lines overlap? Or
Yes, where the lines overlap.
I thought it was when the 2 points intersect.
That is a solution of a system of equations. So if these were equal, we'd be looking just at that point. But because we have inequalities, we're looking at everywhere where the two things overlap.
A range.
Right, so we get a bunch of points instead of just one. So we're going to check 0, 0. For the first equation, is 0 greater than or equal to 2 times 0 minus 1? I'm plugging in an x and a y here. This is x and y. Is 0 greater than or equal to negative 1? Yes. 0 is greater than or equal to negative 1. For the second one, we're saying is 0 less than negative 0 plus 2? That's my x and my y. 0 is less than 2? Yes. So this point is in the solution to that system of inequalities. All right, questions there? Okay, let's look at another one. Y is less than 2x plus 4 and negative 3x minus 2y greater than or equal to 6. Well, this one's okay because we already have y by itself on the left-hand side. But this one we need to do a little work. So the first thing I'm going to do is get rid of this negative 3x. So I'm going to add 3x to both sides. So when I do that, I get negative 2y greater than or equal to, I'm going to write this as 3x plus 6. And now I need to get this negative 2 away. So I'm going to divide everything by negative 2. These go away, and I get y. I'm dividing both sides of an inequality by negative 2. What happens here? The arrow turns around. Less than or equal to negative 3 halves x minus 3. So when we multiply or divide by a negative, we have to switch our arrow. So here's one equation that we're going to graph, or one inequality. Here's the other inequality that we're going to graph. We know for this one, it's going to be dotted because it's just less than, there's no equal. Oh, and I realized on my last example, this line should have been dotted, shouldn't it have been? I wrote that it should have been dotted, but I didn't graph it dotted. So there, whoops, that's not good. So now we have a dotted line. All right, so this is going to be dotted, and we're going to shade below because it's less than. This is going to be solid, and we're going to shade below. Solid because we have an equal, and we're going to shade below because we have less than. So let's make those graphs. I'll be careful this time and make sure I graph my dotted line. All right, so this first one, the y-intercept is 4. So we're going to start there. And my slope, I need a couple more dots. We're going to go up 2 and over 1. 1, 2, over 1. So I get another point there. And I'm going to graph this one dotted. Make sure I get this one dotted here. Like so. Oops, I want that in blue. Undo that. That should be blue. There's my dotted line. And we're going to shade below. So I'm going to shade over here. If you're not sure, you can start on the line and say I need to go down. So I need to shade in this area. All right, so we're going to graph this one. The y-intercept is -3, so I'm going to start down here. And the slope, I need a couple more hash marks here, is -3/2. So we're going to go down 1, 2, 3, and over 1, 2. And we'll graph that line solid. Solid, there we go. And we're shading below again. So start here, I go down. So our solution is going to be all this area here where these blue and green lines overlap. So down in this area here. And because we're just looking for where they overlap, I could stop shading the green here, but it's not incorrect to also shade over here in the green, but we're only looking for the spot where they overlap. All right, questions there? All right, I want to look at one example where we're going in reverse. So we did some of these the other day, but I want to look at one with a system where we're doing the problem in reverse. So the question here is, what system does the graph represent? And I'm going to draw a graph here. Now I'm going to graph another line, and this one is going to go through this point. And this one's going to be a dotted line. And I'm going to shade in here. So we want to know what system of inequalities this graph represents. So we're going to do like we did last time when we had a picture of an inequality. We're going to figure out what the inequality is just for each line. It's kind of like doing two problems in one. So let's look at this line. It's a solid line. And are we shading above or below this line here? This line. We're shading below. So it's shaded below. So we know that our inequality is going to be less than or equal to. Solid gives us the equal, shaded below gives us less than. So we get y is less than or equal to. We need to figure out the slope and the y-intercept of this line. Well, I look at the graph, the y-intercept, yes? Y-intercept is -2. And the slope, so I go up 1 over 1, 2, 3 to get to that point. So my slope is 1/3. And now for this line, it's dotted. And for this line, for the dotted line, are we shading in here? Are we shading above or below the line? For the dotted line. Above. Because if we're here, we have to go up to get to the shading area. So we're shading above. Shaded above. So we're going to have greater than. So we have y is greater than. And we do the same thing. We look at the dotted line and find the slope and the y-intercept. Well, what's the y-intercept here? It goes through this point also. -2. The slope, up 1 over 1. 1x minus 2. And this would be my system of inequalities. I could write these two together, but the system of inequalities is represented by these two inequalities. We just figure out the inequality for each one separately. All right, questions there? Okay. Our homework is a worksheet. Stop this.